applications of log scales are earthquake intensities, sound intensities, and pH scales. So those are sort of the ones that we're going to concentrate on. Okay, so the Richter scale. Anyone experienced an earthquake? Good? Well, not good. I grew up in Victoria, BC, so that's near the San Andreas Fault. And so we actually, like my mom has an earthquake kit. In case something bad happens, earthquakes happen quite frequently. Nothing has been devastating there. But if you ever travel down to California, like for example, San Francisco, I remember seeing on some buildings, because there's a lot of very old buildings, brick buildings, that kind of thing, they have plaques that they put on once it's been earthquake sort of proof. So the building has actually had some stability, extra stability things done to it to make it, maybe not proof, but sort of to be able to better stand an earthquake. I do remember being in Palm Springs at this wildlife reserve kind of thing. And my husband and I were there, and there's people around, but obviously lots of animals. And then, but there's no vehicles, right? So then there's this rumbling, and I mean, it sounds like a truck, right? It's a truck coming. I'm looking around like, not a truck, like you have to walk everywhere there. And then we realized that the ground was shaking and the animals were kind of going crazy, right? So then some of the workers were trying to get the animals in their safe surroundings. And then when we left, we realized, we found out there was a big earthquake just in Mexico, but it was big enough that we had felt it in Palm Springs, California. So hopefully never a bad one, right? So, Richter scale is used to measure the intensity of earthquakes. When the intensity of an earthquake is measured, it is compared to the intensity of an explosion of 14 kilograms of TNT, which is referred to as the reference intensity. An earthquake with a magnitude 1 on the Richter scale is 10 to the 1 times as intense as the reference intensity. So sometimes we say that tenfold. So each increase in 1 on the Richter scale multiplies by a factor of 10, okay, in terms of intensity. So an earthquake with magnitude 7.2 on the Richter scale is 10 times more intense than a magnitude of what? 6.2. Got to be a smaller magnitude. And for each increase by 1 is a magnitude of 10 times more intense. 100 times more intense than 5.2. 100 is 10 squared.
You're in a magnitude 7.2 earthquake, you should be.
Yeah, it's not a good one.
Not necessarily.
No, not necessarily, but
especially in Japan, their architecture is very, very reinforced. We got an earthquake here, everything would collapse. Like an earthquake that bad.
Okay, so let's look at the actual equation. So the magnitude, the magnitude of an earthquake as measured using the Richter scale is given by this formula. So M for magnitude equals log, common log. I is the intensity of whatever earthquake you're talking about compared to the reference intensity. Okay, so we don't use the reference intensity. We're always going to be comparing two earthquakes or two loudness of sounds or two pH levels. So the first question gets us to get the equation so that we can compare. So it says two magnitudes of two earthquakes are M1 and M2. Use the formula above to show that the ratio of the intensities of the earthquakes I1 over I2 is equivalent to this. Because that's how you're going to calculate the ratio of the intensities. So, so let's take a look here. So we have two earthquakes, M1. So this, for the equation, would be M1 equals log of I1 over the reference intensity. Okay. M2 would be log of I2 over the reference intensity. And let's get rid of the logs, right? We want to somehow get it in exponential form. So, convert this to exponential form, we get I1 over I naught equals 10 to the M1. That's just your swoopy swoop. Next one, I2 over I naught equals 10 to the M2. Okay. And we want the ratio I1 over I2. Okay, so you could multiply through to get I1 by itself, I2 by itself, and then divide those equations. You can divide equations. We talked about that with function notation. But why bother doing that? Let's divide these equations right now. Because if I take I1 over I naught and divide by I2 over I naught, these divide out, they cancel out. Okay? So I'm going to divide, so basically you can go like this. Divide those two equations. Okay, so this is going to end up being I1 over I2 equals, now we're dividing powers with the same base, so we subtract the exponents.
That one. Even in Japan, like, that caused so many problems. The 9.2.
Oh,
If you have a chance, do some research on what happened. It's actually more, like, it's more fun.
Yeah. They're not good. They're not good.
It also causes tsunami. Yeah. So,
That's what they worry about on the West Coast is tsunamis as well, right?
insult to injury.
Okay, so that's what we can use to compare intensities of earthquakes. So here's one here. So the one in Japan had magnitude 9.2. The one in Guatemala had a magnitude of 7.5. So obviously the one in Japan was more intense. Okay? Determine how many times more intense it was. So I'm going to put, so basically it'll be intensity of Japan over intensity of Guatemala. Okay? How many times more intense? So that's going to end up being 10. So notice they match up. So if this is I1, then the first value in the exponent is M1. So this has to be the magnitude of Japan minus the magnitude of Guatemala. Basically, you need a positive exponent there if you want the numerator to be more intense. Means the value is going to be greater than 1.
You also use trig identity, or sorry, trig identity. No, do not. Log the identities to do this.
Well, you can, but you don't.
Yeah, you don't have to.
So that's going to be 1.7. 10 to the 1.7. So then don't leave it like that unless it asks you to. It says round to the nearest 10, so we actually have to find the value. So 15.1 times is intense. So Japan's was saving a bit of space there. There's no units for intensity.
Oh, it's
about what kind of value should I end up getting. So earthquake in town A had a magnitude of 3.5. Determine the magnitude of the earthquake in town B if it was 1/3 as intense. So is it going to be a smaller value for magnitude if it was 1/3 as intense? Yeah, it's not as intense, right? So it's going to be a smaller value. So in any case, you might think, okay, want to find M, so we're finding this, we're trying to find MB, okay? And we're comparing intensities. So the intensity of B is 1/3 the intensity of A. So sometimes I write that out and then come up with the ratio, okay? So here, if I want to find, so if I go IB over, not IB, but IB over IA equals 10 to the MB. So that's just our equation from what we initially know without putting this in here. So now, I can either solve for, I can substitute 1/3 IA in there if you want, or you could solve for IA and put it in terms of B, totally up to you. But I'm going to substitute. So now, this is going to be 1/3 IA. And you don't even need to, if you know it's going to be 1/3, then just put it in. But some of you might want to do the substitution. Okay, so now you can either convert to log, so you can take the log of both sides. Sorry, how did you know that I go number IA doesn't matter.
Yeah.
Because you're just trying to find MB, so wherever you put. If you flip this, then this is going to be here and this is going to be here.
It's an S. Sure. Well, yeah, you can get an S.
Okay, so you can convert this to logarithmic form, or you can take the log of both sides. Basically, remember, this is base 10. So this is, so MB minus 3.5 is the exponent, where you have the log base 10 of 1/3. And remember, log base 10 of a fraction less than 1 is going to be a negative value. So that means it's going to be smaller than 3.5 because you end up subtracting. And 3 point, what does it say to round to here? Actually doesn't say. So, no. Anyway, we'll go to the nearest sides then. Okay, so it's smaller than 3.5, which means it's less than 10.
It's, well, that's just the same as minus log of 3.
That's what you're solving for if you have IA over IB.
I think either way it would.
Oh, that's great. Great things. Did everyone go to the IA meeting yesterday to take this out?
Hey, really?
Once it's posted on, you can take a look at the video.
Okay. For those that didn't go, that's their loss.
Okay, so if you talked about in science, I'm sure you have decibels, loudness of sound. Physics? Yep, absolutely. Okay, so last. Okay, listening. Richter, are you ready? Put your back down and enjoy your time. What's that? I know, but like, you don't have to cram yourself in there, like. Okay, so the loudness of sound is measured in decibels, dB. The loudness of the sound is given by the formula, dB equals 10 log I over I naught. I is the sound intensity, and I naught is reference. Since there are 10 decibels in a bell, another formula that can be used is bells equals log of 1 over I naught. So, depends on what units you're given. And you might want to convert to this because then there's no coefficient, right? So, we'll see how these questions play out here. So this is a good one because it says normal conversation has a decibel level of approximately 60 decibels.
Whereas our conversation here has a level.
Oh yeah, sorry, that's the next one. I think we were on the next one. Yeah. Oh yeah, I thought I did one about compared to you guys and compared to regular. In any case, power saw has a decibel level of 110. Determine how many times more intense the sound of the power saw is compared to the sound of normal conversation. So intensity of the power saw over intensity of the normal conversation, okay, is going to be 10 to the bells of the power saw minus bells of conversation. Okay? So you need to, in order, because basically this is just like the magnitude of an earthquake formula. Okay? Absolutely the same, but it had to be in bells. So this in bells is 6, this is 11. Okay? So that's what I would do. Okay, so now we can actually find how much more intense. So that's going to be 11 minus 6. This, you don't need a calculator. So power saw is 100,000 times the sound of the power saw.
I think a power saw is way more intense than a normal conversation in general.
Yeah, it's 100,000 times as intense.
The thing is that our normal conversation level.
Okay, so very same. So if there's any question, like on a test, if we're using some application with Richter scale or decibels, we'll give you, we may not give you this form, but we'll give you this. Depends on the situation. Same with the diploma exam, they'll give you that. They'll give you the ratio of, not the ratio of intensities, but the magnitude of the Richter scale. So you don't have to memorize those, right? But you have to be able to use them. And they're all kind of similar. The one that's a little bit different is the next one, which is pH. Okay? And again, in chem, hopefully you've talked about pH.
Oh, yeah.
Better up.
You're doing chem ID, and we feed this to the data.
Okay, so
Better.
0 to 14.
Actually, it's
pH scale. Well, I know, we're going to keep it from 0 go to 14 for now. Okay? Folks listening?
Once you get beyond that, then it gets
Okay, so pH scale measures the acidity or alkalinity of a solution. It's a logarithmic scale of base 10. The pH of a solution is a scale that measures the relative acidity compared with pH neutral water, which has pH of 7. Okay, so sometimes it's about understanding what's being asked. Okay, so obviously just in general from your chemistry knowledge, down here, the hydrogen ion concentration is big. The bigger it is, the smaller the pH number. Okay, the more acidic it is. So the more hydrogen ion concentration, the more acidic it is, and the smaller the pH number. So just always have that in your mind. So let's think about the relation between two values. So we've got a solution with a pH of 6. How many times as alkaline as a solution with pH 5? So we're comparing these. So 6 is more alkaline. It's 1 pH value. So how many times as alkaline is that? 10. 10 to the 1, right? Okay, now pH of 6 compared to 5, well, it's less acidic. It says how many times as acidic a solution with 5. So now this is going to have to be a fraction or decimal. So 1/10 or 10 to the negative 1 or 0.1. I always have to read these really slowly to look at the pH and think about which direction it's comparing it to. So a solution with pH 5 is how many times as acidic as a solution with pH 6. If it's to the left, and you're talking about acidic, it is acidic. So it's going to be 1 unit in pH is 10 times. And now those same numbers, when we talk about 5 compared to 6 in terms of alkaline, it's going to be 1/10 again, 0.01. So that just gives you an idea, like, in terms of checking your answer, does your answer make sense in terms of being more acidic, less acidic, that kind of thing. The actual formula for pH is there. And I know there's maybe some units or what you use for this.
actually right here.
Hydronium, yeah. Back in the day.
Well, I mean, we always knew it was hydronium. That's what they taught us. So, yeah.
We called it hydrogen ion back in the day. So, in any case, so that's the concentration. So you can find, obviously, the pH if you know that concentration. You just substitute it in. The more acidic the substance, then the higher the concentration, I already went through this, of hydrogen ions or hydronium, but the lower the pH level. Hence the negative coefficient in the formula. Okay. So as the acid level in a substance, you can either say increases or decreases. So as the acid level increases, then the pH level decreases, or vice versa, right? Okay, so first one is pretty easy. It's just substituting into the formula, determining the pH. nearest 10, 4.2. Okay, then now we know the pH and we have to get the concentration. So just be careful. You've got a negative in front. So I'm going to bring the negative to the left. I just said nearest 10, so don't worry about significant digits. Okay, so scientific notation, that's not scientific notation, right? Those of you in math last year, when we did scientific notation in IB, and you do it in science, and then most of you got it wrong on the test that we gave you. Oh, scientific notation, the first number has to be between what? 0 and 1, 1 and 9, 0.999, 1 and 10, basically. Yeah. Greater than or equal to 1, less than 10.
9.9 repeating is 10.
Jackson. Okay, so 10 to the exponent, negative 6.2. So it says to round to the nearest 10, so 6.3 times 10 to the negative 7. And this would be moles per liter, right?
Yeah. Forgot the H plus.
Oh, what did I
Moles
do?
of H plus.
Oh, you have to do that too.
Not the all.
You get mad at us when we're like,
Actually, you know what? If you want to make it really nice, just put, hey, stop. No.
Oh, that's true.
We're not doing significant digits right now. It says round to the nearest 10. Same with the
No. No one uses that. No one. Oh my god.
No, not there. Other side.
Oh! Johnny. Again, gray hair is growing.
Alright, we're just going to leave this.
We're not going to take parts off if we don't have the age to watch. Okay. Okay, let's focus. We don't have that much time left. Okay, so these ones I have to think about, so I need some quiet. We all have to think. So it says, determine how much more acidic a solution with a pH of 4.3 is than a solution with a pH of 6.2. Okay? So, smaller value, it's more acidic. So, you may want to go and look at, so if we go back to comparing our, so we're basically trying to compare our hydrogen, oh, that's not what I want, H plus.
How many hydrogen?
Okay, so with the pH, I'm just going to call this A and this B. Okay, so A over B. Okay.
No.
What's wrong with that?
Oh my god. Okay, that implies that it's A H's bonded together and it has a plus one charge.
Help me, math class. Help me.
All right, leave me alone.
Just
Leave me alone.
leave me alone. Hey, just mellow. Okay?
Does this happen every year?
No, actually, it doesn't. So, I'm calling this listening hydrogen ions of a solution. Solution A. Let's deal with it. Let me call it that. And this will be for solution B. Got it? Just deal with it. Okay? Now, am I going to put 4.3 up here for A as my first one? So if we think about pH of A is negative log of hydrogen ion of A. So if I'm looking at this, then this value, hydrogen ion of A, is equal to 10 to the negative of the pH of A. So this is going to be equal to 10 to the negative of the pH of A. Okay? And then I'm going to subtract the negative of the pH of B, which when I subtract a negative is like adding. So this is really going to be 10 to the 6.2 minus 4.3. Okay, so what you can think about in your head, so this is A over B. For magnitudes and decibels, then this was A minus B. But because of that negative, here you can change it. You can show it like this, but then the pH of B is going to be your first minus your second. Okay? So, from here, if you take a look, I'll erase this one second. So there's your equation, right? For pH of A is equal to negative log H of H plus A. So if I were to solve this equation for H, the hydrogen ion of A, that would be equal to 10 to the negative pH of A. Right? Bring the negative over, 10 to that value. So I would put that on top, 10 to the negative 4.3. Okay, then for this one, it would be minus the negative 6.2. When I subtract a negative, it's like adding. So basically, for pH, because of that negative, if this is A over B, then it's 10 to the B minus A. You want to just go straight to that, switch them around, and then you don't have to do subtraction and negative and changing the sign. Okay? Now, once you get your answer, if it doesn't make sense, then probably you got them switched around. Right? So go back and fix it. So sometimes you might do it really quickly. And so, for example, so let's do this one. So that's going to be 10 to the 1.9. So 10 to the 1.9 is 79.4 times as acidic. Okay? And should be bigger than 1 because this pH is smaller than this. So it's more acidic. So it needs to be a value bigger than 1. If I got something, say I did it the other way around. So I'd end up getting negative 1.9 as my exponent. I get a number less than 1, which means I mixed up the order. Because that's saying it's actually less acidic. Comparing that one to the other one. So always check, does it make sense for your question? Okay. this is 79.4 times as acidic. Okay, so now we're looking for pH values. So solution A is 400 times more alkaline than solution B. So if you think about it, A is here, B is here. 400 times more alkaline, so it's to the right. B has a pH of 12. Okay, so A is going to be bigger than 12. That's what we, if we don't get a value bigger than 12, then we probably switch them around. Okay? Determine the pH of A to the nearest 10. Okay, so in this case, so you might want to do, so more alkaline means that 400, so this will be 1/400 of B. So if we're going from, so this one is to the right, okay, and it's more alkaline. So it's, A is 400 times more alkaline, so if we're comparing the hydrogen ions, right, that's what makes it acidic. So we have to do that ratio. So you could show it if you wanted to. Oh. Okay, so you can set up a ratio like this. So maybe you want to go, if I divide this, so if I go 400, actually, I'll do the same from here. Same as the last one. Okay, so then this is going to be 10 to the pH of B minus, remember they switch around. Right, so this was A, this was B, but they switched. You want to keep it as positive pHs. So that's your general pH equation. Okay, so then you can either substitute 1/400 H of B in here or 400 H of A. Again, totally up to you how you want to think about that. So I'm substituting this in there to get this. And so really 1/400 equals, and now pH of B is 12, and we're trying to find pH of A.
You're always flipping it up.
And you can flip it. Again, we know that our pH of A should be a number bigger than 12. So if you don't get a number bigger than 12, you likely switch either the pH is around or you switch the 400 numerator to the denominator. Remember, I've got log of 1/400, that's going to be a negative, so when I'm subtracting the negative, I get a positive, so I know my number is going to be bigger than 12. Okay, so unless I've done some other error, I'm doing the right thing. is 30 times more acidic than solution B. Okay, so solution A is 30 times more acidic than B. So A's got to be on the left, B on the right. B has a pH of 12. Okay, so same as the last one. But now A is on the left here. Determine the pH of A. Okay. So 30 times more acidic, that means you have 30 times more hydrogen ions or hydronium or whatever you want to call it. So you can set it up like that if you want. And then I like to just think about my ratio here. And so A is equal to 30 A to B. So if I substitute that in there, then I'm going to get 30. And you can show that if you want, but those are going to divide out, right? Okay, so pH of B is 12, and we want to find pH of A. Convert it to logs. This is going to be a number bigger than 1. We're subtracting it from 12, so that's going to give us a smaller value than 12. So we know we're in the right thing. pH of A is 10.5. Okay, so the last two examples there, they actually give you the equation. It's just a matter of substituting in. So you're solving for capital T in question 1. The other examples in question 2, you're solving for T in lowercase t in that case. Okay, so I'll leave those two for you to do. And then, of course, there's exercises, there's some answers there, and there's some stuff. So, I finished exponents and logs. We're going to review sequences, geometric sequences and series of plural, and then talk about sequence notation, subtraction, and division. Okay?